All right, thanks everyone for coming. So just before we start, because I'm not really sure what half of you do, can you stick your hands up and let me know if you're a developer? Okay, quite a few. What about if you're a tester? Okay, no testers, brilliant. Okay, cool. Okay, so I'll get off easy today, hopefully, maybe, we'll see. So I'm talking about testing. And I'm going to start off, before I start talking too much about testing, I'm going to give kind of a brief potted history of software delivery and how it's changed over the years, and then how that impacts what we do in testing and development, and then talk about what we can do, or an option of how I think that might pan out in the future, what we can do about it. So let's start off, software delivery is changing. I think actually software delivery has already changed. If we look back over the last maybe 10 years, it's changed quite a lot. So if we look at this is the State of DevOps report from 2017. So it's an extract from it. What the State of DevOps report does, they send out a survey every year, and they ask for people working in software teams and software companies to answer a questionnaire about ways they work, and how the idea is to work out how DevOps is kind of stretching across different industries and how much it's kind of being picked up by teams. So one of the things that interests me here was one of the questions they ask is how often do you deploy into production? And they kind of segregated the respondees, the answers, into two groups. So they call them the low performing group and the high performing group. So the orange bar is the high performing group, and it's obviously jumped up massively, the number of deploys per year. Since 2015, we've seen a big jump up. It's kind of stabilizing out, but it's stabilizing at about 1,600 deploys a year, which is a lot of deploys a year. Yes, some of them will be quite small. Probably most of them will be small. But if we're deploying up to 1,600 times a year, that impacts kind of what we're deploying and how we go about testing it, and how do we make sure it's working. So we're releasing more often. Our code bases have got bigger. So this is some data that I dragged out of the internet about Photoshop. So I'm sure you've all heard of Photoshop, a big image manipulation piece of software. So it got released around 1990, and at that point it had about 128,000 lines of code. When they released CS6 in 2012, that code base had grown from 128,000 lines of code to 4.5 million lines of code. And yes, lots of new features got added. It looks much shinier. But if you go from 128,000 lines of code to 4.5 million, I think there's a lot more chance of finding problems in 4.5 million lines of code than there are in 128,000 lines of code. So our code bases are bigger, which adds to the complexity of how easy it is to make sure we've got high quality software. Our teams have also changed. If we look at kind of the way teams and companies were structured back in kind of the 2000s, the majority of software teams were set up as a kind of a project-centered team. So you'd have an organization generally was segregated into kind of areas of specialty. So you'd have the development department, and you'd have the testing department, and you'd have the data team. And then when you were starting a new piece of software development, you would create a project team, and you would select people out of each of those departments, and you'd create this project team, and then when the project was finished, they would disband, they'd go back to their kind of homes, if you like, and then another project would kick off. So if you started to have application code base that had multiple releases, they were often split into multiple projects. So you'd have a potentially different team of people coming in each time that software was released. If you look at now, what we're finding is a lot more software teams are picking up this kind of product-centric team structure, so like an more agile team where you've got a team that lives for the life of the product. So people don't move in and out of that product team as frequently as they do with a project team. And you tend to have people working from different areas of expertise, but they're all in that same product team. And then their kind of development center of excellence kind of concept, instead of it being a department now, is much more, it's starting to get, the trend is becoming much more that they are becoming more community of practice. So less formalized groupings of people to kind of pick up that kind of best practice. So our teams are changing. There's also just loads more stuff that we have to test. So some buzzwords up on the slide. So this is just a collection of things that we might want to test. So I'm going to pull out a few of them just as examples. So device testing. So if we look back in the 2000s, most corporate software was just deployed on the company intranet maybe, or an application that gets put onto your company machine, and you access that through that one interface. Now consumers and end users of the applications are expecting that they can work in a more kind of fluid way, so they can work in different locations, they can work with different devices. There's an expectation from most users now, even for corporate software, that they'll be able to use that application on their tablet or on their phone as well as their desktop. And we're also starting to see a lot more different desktop computers coming into companies. So there's quite often a mixture of Macs and PCs, and even within the same OS, we're seeing a lot more mixture of different browsers for browser-based applications. These all adds to the kind of complexity of what we have to be coding for and testing for. If we look at APIs, so back in the 2000s, applications still had an API, still a good way of designing an application, but the API for the application tended to just be an implementation detail of the application. Now more and more APIs are becoming a product in their own right, even for internal systems. So we have to start looking at the API as a product and testing for it explicitly, so that we can then start creating mashups of different applications using the data from different applications' APIs. So this becomes now a new interface for the application that we have to start coding for and testing. UX. So I think this is something that's coming up more and more ever since the iPhone came out, and people started to have a more of an interest in usability and ease of use, and they're starting to see their consumer applications they're using being much easier to use than their corporate applications. So now the demand for end users is starting to get to the point where the expectation level is set that all applications are easy to use and they look pretty, and that they respond to different device sizes, and they just become more like a consumer application. So this adds complexity to the work we have to do as a software delivery team. So we have to then start handling all these different devices and different user journeys through the application and make sure they are easy to use. We've got monitoring. So this is now starting to build a bit of momentum, where we're starting to release more and more frequently. So what happens is we start to need to look at the application in production running and try to understand why it's working in the way it's working. Use monitoring as a feature in the application that we can use to identify whether there's a potential problem and find that before the end users find it. So monitoring isn't something we just get for free. It's something that we have to build into the applications we create, and we have to test and make sure it's working. So this is another area that kind of adds to the volume of work that we need to start delivering. And then the final one I want to bring up out of this list is feature toggles. So if we're releasing 1,600 times a year, the chances are most of the features that we need to implement can't be delivered in one hit, that we can deliver however many times that is a day, say 10 times a day. So we're going to have to release things into production that are partially finished. And one way that we support that is by hiding that functionality behind a feature toggle. And so then the user doesn't know it's there. And then when we finished building it and we're happy it's working, we can switch that on. And then that feature is available to everyone. And that's great, but it does add another level of complexity to the testing scenarios we need to pick up. So we need to start testing how does the application perform with this feature toggle turned off, make sure it works the same way as it did before, and then we need to switch on that feature toggle and check that the new functionality is working as we expect. And that's probably not a big deal when we're talking about one feature toggle. But as that starts to grow and we might have 20 feature toggles, it becomes this exponential problem where you start to have more and more combinations that we need to start catering for. So this is the stuff we're kind of doing now, things that we know about. What about the things that we're not yet using as a mainstream thing? So virtual or augmented reality, voice as an interface and kind of chatbots, text as an interface, and artificial intelligence. How are these things going to come in and impact our ability as software delivery professionals to deliver high quality software? How are we going to test that the artificial intelligence component that we've implemented is actually doing the right thing? So these are some of the kind of, I guess, challenges and things that have changed over time since I'm looking kind of to the turn of the century. God, that sounds like ages away, the turn of the century. So 2000. So things have changed quite a lot in the last 17 years. Let's step back a little bit. So this is some pretty old data. Finding defects later is expensive. So this got presented in 2009 by a guy from Google. And they, I think, were the first company that actually started to quantify how expensive it was to find a defect. So they started to put dollar values on finding defects. They said, right, if we can find a defect before we've had to spin up and deploy anything in our environments, then it's down here, it costs about $5 to find that defect and to fix it. If we have to wait until we've got a whole environment set up and working, and we find the defect, then that goes up to about $5,000. So as an industry, we're constantly looking at how can we reduce this cost by moving things to the left. And one of the ways that we've done that is automating stuff. So automation's great. It's a really good way of speeding up testing, so we can start to run the same test multiple times. It also gives us much more consistency across our tests, because you don't have a human doing it. Humans are terrible at doing the same thing over and over again, whereas computers are pretty awesome at doing the same thing over and over again. So we're driving, as an industry, to automate more and more things to help us find issues earlier. But it's not a free lunch. There are costs to automating things. So one of them, I'm going to highlight a couple. So testers need to understand more. So this is a testing triangle. I'm sure you've seen something similar to this before. So this talks about this shows how we want our ideal test suite to look. So we want to have a really wide base of coverage at the unit test level. Unit tests tend to be really robust and quick to run. They don't tend to be very fragile. So we want as much as we can down at this unit test level. And then as we go up and we require more and more parts of the system to be provisioned, we want less and less tests. And at that point, we only really want to be testing the things that we can't test at this lower level. So when we get up to the end-to-end testing, we're relying on all of these tests finding potential problems. And we're only really testing here that the UI is responding correctly and it's being wired up to the back end correctly. So this, I think, sounds logical. It's quite different to what we used to do when we were focusing a lot on manual testing. If you look at an equivalent testing triangle for a team where they were generally manually testing, you'd find really that the testing teams only really focused on this part. You're manually driving the application, so you tend to drive it through the interface that the end users see. And that has a bunch of benefits, and that you know that everything's working if you're testing it through the UI. But it is time consuming. But one of the things it does allow you to do, you don't need to really care about any of this stuff down here, because you're testing everything through this front end. So a lot of testing teams got to the point where they might have had conversations with the development team about how much testing had been done. But really, if they were being honest, they just ignored all of that, and they tested everything through the front end anyway. So developers could do as many unit tests they like, but they didn't really add any value to stopping work that the testing team were doing. If we're moving more towards this kind of setup, and you're still having the testing kind of team as the group of people who determine that we've got sufficient testing coverage, then in order to understand what tests we need at this level, they need to have a pretty good understanding of what all these tests are doing all the way down the stack. So there's a bit more complexity that the testers need to understand. We're also finding as we're adding more and more automation, this is all code, all goes into our code base. And we're starting to find code bases, the testing part of a code base, becoming quite big. So this is some data from one of the applications we've been working on. It's about 18 months old. Well, the application code base is about 18 months old. It's had about 6 developers working on it. We did a pretty basic check just on counting the lines of code, just to see how many lines of code are in the application and how many are in kind of unit tests, our unit test projects, and how many of them are in our BDD testing, so our end-to-end testing. I'm not putting this up as an example of best practice, it's just a data point for interest. But we found we only really had about 30% of our lines of code in our code base was application code. The remaining 70% of the code we'd written and have to maintain is purely there to test that the 30% is working. So if we're talking about 70% of your code base being test code of one type or another, then we're talking about a lot of code, and we start to bring in a whole bunch of questions around how do we use engineering best practice in order to make sure that 70% is maintainable code that we can look after and make sure is working well. So my kind of statement is that modern testing that we're doing now requires quite a lot of development experience, development skills. Now, this is not a new piece of information. The testing community especially have known about this for several years. If you've been to any kind of testing focused conference in the last 5 or 6 years, there's always at least one, probably more, talks that are titled something like, to survive as a tester, you need to be able to code. So I thought I'd look at that. If you're asking testers who traditionally are testers because they don't want to be software developers, and you're saying, well, actually, you've got to now be a software developer in order to be relevant as a tester, what does that actually mean? Can testers actually become decent developers? So in order to answer this, I thought I'd go back and look at what a tester brings to the team. So I've split it into two. So if we look at the coding skills we need in order to be a kind of a modern tester, and we're looking at automation here, there's a lot of information we're going to have to pick up. So we've got web development skills. So you're going to need to know something about HTML, JavaScript, CSS. If you're building a web app, obviously if you're building a desktop app, then there's a whole different box that appears. You're going to need to know something about automation testing and the tools around that. So Selenium and Cucumber, the Gherkin syntax. You're going to need to know a little bit about unit testing and API testing and how you might go about that. You're probably now going to need to know something about security. So either that being kind of OWASP type security, or whether it's things like network security. You need to have some sort of understanding of that and around authentication, authorization mechanisms. You're likely to need to know something about where your code is going to be, where the application is being deployed. So that's either some sort of cloud understanding, or it's going to be some sort of continuous delivery, continuous deployment setup. You're going to need to know a coding language, at least one, probably a couple of these, so Python or C# or Java, something like that, and you're probably going to need to know a bit of SQL. And if we're talking about building 70% of our code base, you're probably going to want to know something about how to design and architect a decent sized code base. Now, when I look at this, the coding skills that you need in order to be a good developer as a tester, I think that's a lot of stuff to pick up. I'm sure you don't have to learn it overnight, but there's still a big volume of knowledge to build up. So it got me thinking, what about if we did it the other way around? What happens? Can we get developers to be better at testing? So I thought I'd look at that. So I thought I'd look at what testers bring to the team. I've split it into 2 bits. So I'm going to look at the traits of tester, first of all. So these are kind of, I guess, non-testing technical skills. So they tend to bring great domain expertise of the application. How does it actually kind of, the environment it sits in, how do people use it? They have got quite a good analytical, logical way of thinking in order to build the tests and kind of understand how that whole test pipeline fits together. They tend to have a test to break approach to everything they do, whereas developers tend to have a test to prove it works well enough approach, whereas testers go out straight away just to see, okay, great, how can I break it? They've usually got pretty good communication skills. They're always talking between different stakeholders in the team, so developers or external stakeholders or project managers and product owners, and explaining why things are not working and why it's important. And they've got a pretty good awareness of the impact that a problem might have on the business. So there's quite often they are the voice within the team of, well, we can't really release with that because look at it, how is a user going to use it like that? So they've got a good awareness of that. And they take on the customer's viewpoint. So it might not be a bug, but they can look at it and go, well, actually, but have you seen how you have to actually get to use this feature? It's a bit clunky. So if you look at all these traits of a good tester, when I look at them, and I look at all the different developers I've worked with, most of the really awesome developers I've worked with have a pretty high number of these traits. So I think the traits of a good tester are also the traits of a pretty good developer. I think if you are better at these as a developer, you are a better software developer. But it's not all about traits. There's also some skills that testers bring. Clearly, this isn't a full list, but it's a list of different skills. So they've got a really good approach where they know how to design tests and understand how to take an application and break it into pieces that can be tested independently and overall create a fully tested application. Coupled to that, they've got like really good risk management awareness. They understand that we can't test everything, and they drill into the bits that are really the most important parts of the test. Yes, they don't get it right all the time, but they get it right most of the time. That's how we can do this risk-based testing approach. They've got good skills in different approaches and ways of testing application. So they know when to use ad hoc and exploratory testing and when a more scripted type of test is a more appropriate way of testing. They know how to leverage black and white box testing and all the other kind of standard testing kind of ISTQB foundation skills. They know how to use those to test the application's boundaries. And often they know about something more specialist. It might be capacity and load testing. It might be security testing. It might be usability testing. They usually bring another kind of skill set. So looking at these, I think that these are also pretty good skills for a developer to have. I think if you can get better at some of those, then I think that helps you become a better software developer. They're not completely orthogonal skills to being a good software developer. So with that hypothesis that I think if you can get developers to be better at some of the testing skills, they'll become better developers. Let's look at how can we go about doing that. So I've got a 3-step process that is partially tested to improving the developers' testing. So first thing I think we need to do is improve developers' awareness of testing and the tests that are going on. I think a lot of times in a lot of teams, developers have a pretty good understanding of how the unit tests tie together, and they probably know how most of the integration tests work. But when they start moving into the tests that the testers do, they couldn't explain, if you ask a lot of people in the team, I don't think they could explain how the tests actually tie together and find the tests. So we want to improve the awareness that the developers have got on the actual tests we're running. We then want to move into improving, 2 things we want to improve here. We want to look at improving testers' awareness of development so that we can have a better conversation with the testers around where the risk is. So if the testers have got a slightly better understanding of how the code is created, then they have a much easier conversation with developers talking about where the risk is and where it's going to break. And coupled with that, we need to start getting developers have a little bit more awareness, not just of all the tests we've got here, but how the testers go about breaking the application. Like, I'm sure as developers, a lot of you've had this situation where you write some code, you test it, and you're feeling very conscientious today, so you've done a lot of developer testing and you're pretty confident it's working. You give it to a tester, and then within about 5 minutes, they come back with a list of things that aren't working. You're like, oh, how did you do that? That's amazing. We want developers to know more about that magic of how that happens, because it's not magic. It's just an approach and a skill set. Once we've got there, at this point, the kind of the final step, I think we need to actually start getting developers more hands-on experience doing exploratory testing. I think we need to make the dev testing that we're doing just more effective and not necessarily more time-consuming, but just a better way of finding problems. And I think at this point, this is when we can really start talking about moving to a proper automated testing pipeline, because we've got the whole team at this point with a really good understanding of how all the testing's working. So this is when I think it's the right time to have the conversation about automating things. If we do that too early, it's very easy to fall into the trap of automating a manual process, which has some benefits, but it's not where we get the full benefit. We want to have a really awesome automated testing pipeline. And that involves everyone having a bit of an awareness of what's going on. So that's my 3-step kind of grand plan. I'll drill into a little bit more detail in each of those 3 and talk about them. So step 1, we're talking about improving developer awareness of tests. So what we've been doing is we started with a pretty detailed conversation at the start of any sprint. Developers and testers sitting together, we talk through what the feature is, and we agree up front what all the scenarios are we want to be testing. So this is really more around our kind of ongoing regression testing, more than what ad hoc tests that the tester is going to do in order to break it. This is what are the scenarios that actually we really care about. Once we've agreed those, then we kind of hand over the responsibility to create those tests onto the developer, onto the development team. So the tester at that point doesn't need to know anything about how to automate, how to write code. They're just focused on what are the right scenarios to be testing, and the development team worry about how we're going to implement it. And that gives us, as developers, flexibility to start talking about, well, actually, this scenario, we can test almost all of it down at this unit test level. But there's a little bit of residual risk that we need to cover, so there's a small test we need to have at the end-to-end level, or whatever the breakdown is. This also frees up the tester's time within the sprint to really focus on exploratory testing, kind of unscripted, clicking around in the application and using their expertise and experience to find bugs. And this is where humans and testers are really awesome. They're really great at taking an application and breaking it. And we want to break that as quickly as we can, fix the bugs, and then rely on that automated kind of regression pack in order to make sure that nothing else breaks in the future. The other benefit we've got here is we're starting to get the developers to really start to buy into that ownership of that test pack. It's no longer a testing thing that they've created. It's a team thing, and we've got the developers know about how those tests are created, and they spend more effort, if you like, looking at making sure that they are passing. So we've got more buy-in as a team. So that's step 1. Let's go into the second step, intermediate level. So here we're trying to do 2 things. We're trying to get testers understanding a bit more about how the machine is created. We're trying to get developers to understand a little bit more about how the tester goes about breaking it. So here, what we're really looking at is pairing. So pairing is a pretty standard thing we do with developers, developer and developer pairing together to build something. We've had good success doing that. Here we're looking at a developer and a tester pairing on a feature, and we're looking at 2 things. One, to have the developer pairing with the tester to do the exploratory testing. So they start to learn more about how the tester thinks and how they build up that exploratory testing. And then separately, we're looking at the developer and tester pairing to build some of the automated tests. So at this point, we're really trying to kind of just upskill the developers on their technical understanding of the application. We're not really focusing on trying to make them like amazing developers at this point, but we're trying to get them to have a better awareness of how the system ties together and what the terminology we're using, and just to be more comfortable talking about kind of some of the lower level geekery of the development world. Once people are happy doing this, I think if we can get to the point where the developers are kind of a little bit better at doing exploratory testing, this starts to free up quite a lot of the testers' time to then start looking at something else. So that could be coding. It could be that they start to have an interest in coding, so we want to make that flourish. But it might be that they want to focus more on some of the more complex or niche testing. So some of that security or the usability or accessibility, all those kind of other bits of testing that aren't the core part of just making sure the core application's working. The last step is where we start to get a little bit more controversial, I guess. This is where we start removing testers out of the team and having developers doing the testing. At this point, what we're trying to get to is the testers need to start thinking of the developers not as developers, but as being really competent testers. They might well be able to code as well, but when the tester looks at the developers, we want them to be looking at them and thinking, yeah, you're actually a very competent tester. So when you say something is tested, I actually truly believe that you have tested it. And there's a mentoring piece of work here where we start having the tester reviewing the testing that the developers have done, and giving them pointers about ways of they could improve that. And some people, that will take longer than others. And once we're happy that the developers are actually performing as good testers, we can start moving the testers out as a full-time role from that team. And they kind of start coming in then as more as kind of a consultancy role where we've got a really specialized piece of work to do. So we'll bring in the specialist expert to bring in and help the team on that piece of work. Or we bring them in just as a kind of more of a coaching role. So they're much less full-time in that team. So that's the 3-step process. It's not completely without consequences. There are some impact of this sort of approach. So I was going to talk about a couple of them. So what happens to the role of testing? Now, I think really what happens with the role of testing is that the developers pick up the role of tester. It's just a role in a team, and they happen to be the person who's doing that testing. But I think longer term, the actual kind of testing role in a team changes. I think it goes into 2 ways. I think one is that the testing role is treated a little bit more like a scrum master. And I don't mean about the kind of the processy parts of it. I mean more a scrum master, the better you are as a scrum master, the more knowledge your team has and the more they can do just without you being around. And so you need to spend less time working with them. There's less coaching, there's less mentoring, and you can start providing your scrum mastery skills to more teams. I think this is one option that testers can bring in. They come into a team and they really help build up that testing knowledge. They bring up the base level of knowledge that everyone in that team has. And then as everyone starts to get better at that, then they can start spending less and less time working with that team. They can start working with other teams. So I think that's one option. I think the other option is that they become more like a consultant. So they start to build really deep knowledge in a particular area. And when you're looking at your backlog and you're planning your sprints, you start to identify areas where you're going to really need one of these kind of specialist skills to come in and really help your team for a short period of time, and then they leave and they go and help another team. So that's the role. Onto the actual people, because there are people at the moment doing that testing role. Again, I think there's two options. So one is, I think there's, depending on the individual, they'll have different interests and different skill sets and different capabilities. But I think the nice thing about the tester, most testers I've worked with, is that they've actually got a really broad range of interesting skills that allow them to position themselves in quite a lot of different roles within the team. Like some testers have a lot of domain knowledge, and so they understand a lot of how the product needs to evolve over time. So they might naturally kind of morph into a more product owner, product manager type role. Another area that testers kind of quite often get into, they are quite often the sort of a processy kind of driven person. They quite often are well, we can't really release this because of X, Y, and Z, we haven't done this. It doesn't really necessarily fit. I've got it as a kind of a Scrum Master role there. I'm not completely comfortable that is really what a Scrum Master is trying to do, but it's probably more of a project manager. Maybe there's an interesting avenue they could look at there. And I think they could also fit into a UX designer or a developer role. Certain individuals, if they've got an interest in that, then we can definitely mentor them and bring them up and help them kind of move across into one of those allied roles. So they can change their role, or they can really start focusing on more specialist testing skills. Testers have got lots of years of experience and expertise, and it's pretty unrealistic to think that over any short period of time we're going to be able to get developers up to the same level as a professional tester. So testers have got a lot of head start to be focusing and looking ahead at all the new things that we need to be worrying about. So they can become the artificial intelligence testing expert, and we'll bring those guys in when we start talking about artificial intelligence. The other implication is I'm talking and painting this picture of developers doing all this extra stuff. And they're not currently just sitting around with loads of free time. They're pretty busy. So why would a developer want to get involved in any of this? I've got 3 selling points. We'll see how compelling they are in a minute. So I think you'll get less bug fixing. I think developers tend to quite dislike testing, but I think the thing they like less than testing is fixing bugs. So if we can reduce the number of bugs that happen, then I think that's a plus point. And I think we can do that by if you're better at understanding what testing is going to be happening, and you can do that yourself, you'll find these bugs yourself before they really become proper bugs. And ideally, you'll start thinking about some of them before you've actually started writing the code, so you can eliminate them completely. I think you can write better quality code if you think of testing. If you build something that is easy to test and easy to maintain, then it's going to be easier for you to make changes to in the future, and easier for you to be able to identify that something's not working. So I think you end up writing better quality code. And I think you end up having a lot more autonomy, especially as we start moving more into a world where we can kind of release whenever we like and everyone is comfortable that everything's working. We as developers have the ability then to release when we like. We also have the ability to say that this is where the tests need to sit. This is much better as a unit test because of X, Y, Z, some detailed code reason, and it doesn't need to be an end-to-end test. We're in a very good position then to be able to make the right decisions, and we can choose what works best for us in a team. So that's my pitch for what's in it for the developers. The question that I'm sure you're all asking is, does it work, or is it just a random set of slides? So I'll give you a few examples of some places it's worked, and I'll talk a bit about my experience. So, in 2011, one of the VPs of Forrester Research wrote an article, and it had a very exciting title. It said, want to improve your software quality, fire your QA team. And one of the clients that was working with Forrester did just that. They were a software company that created real-time financial market data to trading platforms, and they had they decided to remove the entire testing team from their organisation, and they pushed all of that responsibility onto the developers. They didn't follow my 3-step process, but they just kind of got rid of testing and said, well, developers, knock stuff out, release whenever you like. And in their example, they found that they had less defects, they managed to release quicker, and their customers were happier. That's one data point for you. Facebook, in 2012, there was a ZDNet article that interviewed one of the engineering managers at Facebook. And he said at that point, Facebook had no permanent full-time role in their organisation dedicated to QA. They just didn't exist as a role. They just had developers, and they had some kind of ancillary roles that did some bits of QA, but there was no full-time focus. Now, whether we think that Facebook is the kind of shining beacon of high-quality software or not, I think there's a conversation topic, but it was definitely something that was working for them. Another example, Yahoo. In 2015, they had an internal initiative called Warp Drive, which sounded amazing. But really it was around trying to release more frequently and with less kind of ceremony. And the change they made, rather than kind of completely getting rid of the QA department, they changed the rules of engagement so that developers could push their change into production without anyone else looking at it and without anyone else kind of rubber stamping it. So they could make the decision whether they were happy to roll it out. And they could equally make the decision that, actually, no, I'd like to have somebody else look at it, but they could choose what they wanted to do. And they started to find that they were releasing better quality. They had less defects in their production code base, and they were releasing much more frequently. And developers were more engaged, and because they hadn't seen any negative impact, they saw that as a good thing. One last example before we look at me. Atlassian, they've been a bit of a kind of a thought leader in this world of reduced testing kind of teams. And they've got hundreds of blogs and some great talks they've done at conferences explaining how they've gone about it. They've got a much more complex process they followed than the 3-step model that I've proposed. But there's a great talk that the head of QA gave at a conference, and at that point she was the kind of looking at the Jira product team, and they had about 60 software developers producing Jira, and they had 2 people in QA supporting that team of developers. And she was asked, like, how do you get by with having so few testers? And she said that she doesn't think that she's got a small number of testers. She looks at the team and really believes that she's got 62 testers. And she was completely convinced that they'd managed to, over a period of a few years, get their developers at such a high level of test capability that she would be really happy to recommend any of those developers for a QA focused role in another organisation. So she really didn't think of a difference between, it wasn't that she had developers who did testing, she really felt that she had developers who were testers. So if you're interested in all of this, then Atlassian's a great place to kind of read and find out a little bit more about it. And you'll see that I've probably stolen a little bit of their process. Okay, so let's have a talk about Headtalks and teams I've worked with. So how have we got on? How have we found it? So I think we're probably here, step 2. We've had really good success so far in kind of the first step. We've got really good detailed conversations happening at the start of all of our sprints. Everyone's really aware of what test scenarios we want to be running. Developers are building all of those tests, and we are, on the whole, paying a lot of attention to when they're passing and failing, and we're kind of keeping on top of the housekeeping of those tests. What we're really starting to look at now is kind of this skills transfer. So we've sort of started on the pairing to help get testers better at doing automated testing. We haven't really started a lot on the developers getting better at exploratory testing at this point. So that's kind of the next step in our evolution. So we're kind of here. I think there's a bit of hesitance around kind of getting the testers working with the developers to get better at testing. And it surprised me a little bit, because I kind of expected that hesitance to come from the developers. Like, oh, I don't really want to do more testing. I already don't really like it. But it's not really, it's more from the testing side. It's more, the conversations are more, well, if we get all of these developers to be really awesome at testing, then what happens to me, my role? Like how do I fit into that world where we've now got a team full of awesome software testers who can also code really well? Like where do I fit? And so I think there's a little bit more work to do to kind of help that transition and understand that we're not really talking about firing the whole QA team and hoping the quality goes up. We're really talking about improving how developers can get better at testing, and allowing time for our existing testers to really focus on other areas that add value that we probably aren't focusing on enough at the moment. Okay, so just to summarize, I think developers are quite capable of being effective software testers. We need to spend a bit of time working and mentoring and bringing them up and training them in the same way we would with a junior tester. We need to be careful, though, that we don't underestimate the impact of doing that on the existing people we've got, developers and testers, but it's a change and it does impact people. We need to be careful of the impact we have. But I think the driver, the reason we want to do this is it helps us scale better. So if I'm looking at a team and we want to start increasing the capacity of that team, we've got to hire some developers, because they're the people who create the thing from nothing. If we're starting to try to, for every 2 developers we recruit, we need to recruit a tester, that adds limitations to around the amount we can scale. So we're starting to need to find different skill sets. If we could maybe find 3 developers instead of 2 developers and a tester, and have them all being able to do some testing and some development, it allows us to scale in a much more linear fashion. It starts to allow us to build more cross-functional skilled teams, and I think it ultimately allows us to deliver better quality software much earlier. That is the end of my talk. I'm happy to answer any questions, if you have any.
Losing testers as a result of this.
Mm-hmm.
Do you need more developers to make up for that, since each one is doing more stuff?
So possibly, probably. I think it'll be interesting to see, though, because if we are getting developers better at predicting what things won't work before we start writing the code, we're ending up with less problems coming out, and that turnaround time between finding a defect and fixing it becomes less because you don't have a handoff between a person, then I don't think it will be a kind of a one-for-one kind of switch, but I think it's likely that we will have the same number of people in the team, but maybe there's less specific roles. But I don't, that's a hypothesis. I haven't really got any data to support that at the moment. We'll see how that pans out if we get there. Anyone else? I'm going to stun you. Barney.
So do you expect a developer to actually sit down and say, right, I'm now going to spend the next 4 hours testing, or do you expect a developer to have learnt the skills to have thought out what they're about to write and then put in things to stop those tests becoming necessary?
I think that you'll probably do both, because I think at the moment, developers already do the, right, I finished writing it, now I'm going to spend, it's probably not 4 hours, I'm now going to spend 5 minutes testing it. And you do an exploratory test, you click around and you check it's working. You're just, you're asking yourself different questions to what a tester looks at. So if we can change that, and we can, I think you could probably get away with spending not much more time doing testing. We're just doing more efficient, more effective testing and finding more problems. But I think also you'll start to understand what those scenarios are, and we'll come up with ways of stopping them happening in the first place, which I think is where we get that time saving, because we start not finding the defects because they don't exist in the first place. Now, there's still obviously going to be some defects. It's not, I'm not proposing that we're going to be magic and produce software with no defects.
Thanks, Dave.
Cool, thank you very much.